Okay, so good evening, everybody. You're welcome to Scope Africa Academy, a place where we connect business professionals and entrepreneurs, and also a place where you learn one thing or the other about our business from those who have gone ahead. So you're all welcome to tonight's section on a deep dive into IoT, and the class we are having is with Helen, who is a software engineer, and she has been doing great things. So you are all welcome tonight. I believe we have done what she asked us to do, so we can get started tonight. So from now henceforth, Elaine is going to take the platform. So I believe we are all ready. So Elaine, please, you have the platform. You can take over. Thank you so much.
Okay, thank you so much. All right. I don't know if we're able to get the code blocks to work or any C++ software. Okay, all right. I will just share my screen now. Okay, if you haven't gotten your own to start working, maybe you can just use the online ID. Let's be fast with everything tonight. Okay, please indicate when you start seeing my screen. Can you all see my screen now? Please indicate so I'll be sure.
Yes, I can see your screen.
Okay, sir. Okay, all right. I think we start at the if else statement. And today, according to what is in our course outline today, we are going to be building a simple circuit. So all these, the reason why I started with C++, the reason why I came to this environment to introduce you people first to C++, we are going to see that. And we're going to proceed from there. But the main thing we'll be working on is not this C++. We'll be working with the Arduino, which I already said. But the Arduino uses the C++ syntax. It was built from C++. So that is why we need to have just like a little introduction to C++ before we can be able to use the Arduino. Yes. And I think we have two more things to do in C++, and then we enter the Arduino. We'll be creating a simple circuit, and let's just simulate something and see how IoT works. All right, the if-else statement. I believe if you did the assignment, you already understood this if-else statement. You did the assignment, I believe you already understood it. So the next thing we are going to be looking at today is the loops. All right. Yes. In computer programming, loops are used to repeat a block of code. Okay, just like the conditional statements, which are used to like make a certain condition. If this is true, do this. If this is not true, do this. Else, do this. So that is conditional statements. And this time around, we are looking at loops. And in computer programming, Loops are used to repeat a block of code. All right. So loops are used to. Hello. Yeah, I think someone is disturbing. Maybe you can mute yourselves, please.
Continue. Continue.
Okay. So loops are used to repeat a block of code. With loops, you can make a particular line of code to continue to iterate, to continue to repeat itself. You know, from what we have been doing, if the code run once, it will stop. But then what if we want this particular code to keep running? That is where loop comes in. For example, let's say we want to show a message 100 times. Then instead of using the print statement 100 times, yes, we can actually keep copying and pasting the print statement just to print whatever we want 100 times. We can just use loop and write one line of print statement and everything, and it will count and appear 100 times. So that is loop for you. That was just a simple example. We can achieve much more efficiency and sophistication in our programs by making effective use of loops. Now, there are 3 types of loops in C++. Mind you, I'm not going to give you everything here. So I will still do, maybe I will look at one type of loop, and then you can make research on your own on the other 2. So there are 3 types of loop in C++, the for loop, the while loop, and the do while loop. And the good thing is that this loop still falls into the conditional statement, because it is only on a certain condition that the loop will occur. Okay, so all right, I'm going to using namespace std. Please just try to follow me. If you don't have the IDE, you can use the online ID. Okay, remember the comment which I talked about yesterday. So this is the comment symbol. Practicing the for loop. All right. So let me just use the for loop as an example. And this is the syntax. This is the syntax of the for loop. Okay. This is exactly how you should declare a for loop. For initialization, the condition, and the update or the increment or decrement. Okay, so this is exactly how to write the code for a for loop. All right. For initialization, condition, update. Then you open the curly brackets. So now this is not what is supposed to be here. So I'm just using this to explain to you. So this is just like a pseudocode, like a for something. I'm trying to use it to explain to you. Now the initialization, we have to create a variable. And loop variable is usually in integers. Usually in integers, because if we are to count how many times a particular thing is supposed to occur, all right, then it will be in integers. Yeah, numbers, so that we can be able to count. For int I is equal to 0. So we just initialized I to 0. That is the initialization we had here before. So I is equal to 0. Now, what is the condition for this loop to keep executing? I must be less than 5. Okay, which means each time this code runs, I must be less than 5 before it will execute. All right, then the update is this, I plus plus. And what this I plus plus means is that after this runs the first time, I will will add 1 to itself. So I plus plus means I equal to I plus 1. So it's just the same thing as I is equal to I plus 1. So for example, the value of I here is 0, right? Now when this loop runs, I will be equal to 0 plus 1 because I here is 0. Equal to 0 plus 1, which is 1. So I now becomes 1 now. And then it will run again. It will go back to the top because this is a loop and run again. Now remember that I is now 1. So when it's running again, once it sees I plus plus, that is I, the value of I plus 1. The present value of I is 1. So that would be 1 plus 1. That would be 1 plus 1 here. And I becomes 2. So the same way, that is exactly what it will be doing. It will keep incrementing I by 1 because that is exactly the update we gave it here. If this was I minus minus, that means for each time it's running, minus 1 from the value of I. So now this will continue, I plus plus will continue like this until I becomes 5. Which means if I is greater than 5 now, if it's greater than or equal to 5, that means it is out of this condition. And this loop will not run again because the condition we gave it is I must be less than 5 before it will run. Okay, so let's see. See out I. Then let's end line so that we can see everything very well. Okay. Run. I think I have an error somewhere. All right, sorry. This is not supposed to be a comma. It's supposed to be a semicolon. Okay, so this is it. Did you see? I never wrote C out 0, C out 1, C out 2. I never wrote it. But that is the power of loop. I just used loop to count from 0 to any number I wanted to. And if you can see here, we didn't include 5. Because once I became 5, that is once the value of I changed to 5, that means this condition is false and the loop stopped. Assuming I said, okay, if I is less than or equal to, that means I'm going to include 5 now. It's only when I is less than or equal to 5 that this loop we execute. So the first time we run this code, remember, C out, that means we are printing I, C out I. So at every stage of the loop, we are printing the value of I. Now, I was 0 before, and the loop ran the first time, and we printed I. I was 0 at that moment. Okay, so because of the I plus plus here, I this time around became 1. And yes, it's still less than 5. So this code ran, right? And this time around, I became 1. The same way until we exhaust the condition. So now I added equal to 5, which means I can still be equal to 5 and the loop will run. Okay, so let me run it. Now 5 is included because the condition says if I is less than or equal to 5, which means as far as I is 1, 2, 3, 4, 5, this loop, this code here, any block of code inside this curly bracket should be executed. So that is it here. If I had changed this value now and say, okay, if I is less than 10, that means as far as I is less than 10, this code inside this curly bracket will be executed. That means I will count from 0 to 9. If it's 10 now, that means it's no longer less than 10. You see, it's a false something now. So when it becomes false, it will not run again. As far as this condition here is true, this loop will continue to execute. So let me run this code now. And as you can see, yes, 0, 1, 2, up to 9. All right. So why is it starting from 0? It's starting from 0 because the initialization we gave to I was 0. Assuming we don't want I to start from 0, maybe 3 or anything, or maybe 1, we will initialize I to be 1. Okay, let's run it now. You see, I started from 1 because that is the first initial given to it. All right, so you can just play around with these loop values and other. So this is the for loop. This is the for loop now. Okay, maybe I should just touch the while loop. Practicing the while loop. Mind you, this loop does the same thing. Okay, so they like loop through a block of code. They repeat a block of code. All the loops, do while, for loop, and the while loop, all of them do the same thing. Now let's try the while loop. It's just the syntax that is different. As you can see, for loop, we need like 3 things, which is the initialization, which is this, the initialization, the condition, and the increment or decrement, which is this. That is for loop. Now in while loop, this is just the only thing we need. Just give the condition inside here. Okay, so while we don't initialize inside the bracket of the while loop, so I can do my initialization outside here. Int j is equal to 1. Okay, then I will say while j is less than 50. All right, then let's open the curly bracket and put the block of code inside. While j is less than 50, then let's print out the value of j. See out j, end line. And this is it. Okay, now if you notice in this loop, like there was no increment. There was no increment or decrement. Of course, we need an increment so that each time this loop runs, the value of j will change. So here, we can have an increment here. We can say, okay, j should be equal to j plus 1. Okay, so after running this loop, the next value of j will no longer be the initial value. It will be the initial value of j plus 1. So j takes up a new value now. Okay, now let's run this. Okay, you can see it, right? Yes, this is where the while loop started. I think, let me have to enter. Okay.
Hello, Ellen.
Yeah, I can hear you.
Can you close the get started for free box below lower right so that people can see the screen well? Thank you.
Okay. Can you see it very well now?
Yes, that's good.
Okay. I think let's give another line. Let's give a space on the next line so that we'll be able to do, or maybe for things to look better, let's just print out something here. While loop starts here. Starts here. All right. Don't forget this. But if you don't have it, to try an error. Yeah, that's an error. Okay. Your semicolon. All right. So while loop starts here, and as you can see, 1, 2, 3. I never repeated this value, but this is just the only block of code doing this. So you can see the use of loop to iterate through a block of code, okay, to repeat something, to repeat a block of code. So as far as j is less than 5, we keep repeating this block of code until J is greater than 50. Sorry, is equal to or greater than 50. Okay, so if J is no longer less than 50, this loop will stop. All right, so that is loop. Okay, let's see what will happen if we don't actually do this increment. Okay, so this is it. This is it. J is always 1. There is no increment, and this is an infinite loop, and it cannot actually crash your system. So this loop is not going to stop anywhere. It will continue. It will continue. We didn't give it a specific condition to stop. Okay, that is because we didn't increment J. So J is always 1, and it can never ever be greater than 50. So the loop will continue to run. If I leave it now, it will crash the browser and everything. Okay, so J, yeah, you can still do J++. Remember what I said, that J++ is same as J is equal to J plus 1. So I can do J++ here. Yes, the semicolon. And it will work. You can see now the loop ended here. Okay, the loop ended. Because now J is no longer less than 50. At 49, that is where the number less than 50 stopped. 49 is where it stopped. So anything 50 is now false because of this condition given. All right, so that is loop. Okay. I think now we are going to move to the Arduino IDE. All right, before then, yesterday I said I'm going to talk more about the microcontroller. Yes, this. I said I was going to talk about it. All right, so like I said, this is the brain of everything. If you can remember what I said yesterday, that this is the brain of everything. Any device that you want to automate must be connected to this. This is a microcontroller, just like the CPU, the central processing unit. So every device you want to automate must be connected here. And as you can see, these are the pins. We have some pins here. Okay, I'm glad they labeled this very well. Okay, for some of you who have gotten the Arduino kit, the Arduino starter kit by now, maybe you can just bring out this particular thing from there. You can be watching it while I talk. So this thing you're seeing here, this is the USB port. Now, this is exactly where you plug your wire and then connect the other end to your system. So this is the port that enables you to send your code from your system to this microcontroller. Okay, so with this USB port here, you can connect to your system and then transfer your code from your system to the microcontroller through the Arduino IDE. Now, this number 4 is labeled as the digital pins. I know you can see this very well. From this zero till pin 13, these are pins on the Arduino board. So from 0 to pin 13, they are called the digital pins. Now, these digital pins can only have 2 values. It's either it's 0 or it's 1. So any device that kind of behaves this way, they are to be connected in the digital pins. For example, the bulb, you know, is either your bulb is off, right? Or it's on. There is no value between it. It's either it's off or it's on. So it's off when it's 0 and it's on when it's 1. You know that when you want to connect something like a bulb, you should be connecting it to the digital pins. Okay. And other things, maybe something like your fan, yes, is either it's on or it's off. Just anything that behaves in that kind of way, like anything that could be off or on, okay, that is what you connect in the digital pins. Now in the analog pins, and the analog pins, like, you connect something that gives continuous stream of data to it. Something like the sensors, the temperature sensor. You know, the temperature sensor is no longer 0 or 1. Okay, there are readings around it. Okay, so the temperature of this house can be 20 degrees Celsius. The temperature can be 15 degrees. The temperature can be this. So that is exactly the kind of things you connect to the analog pins. And also something like the photoelectric sensor, that is the light sensor. Okay, you know that it's no longer 0 or 1. There are values that it's trying to get. So these kind of things, you should be connecting it to analog pins. You can see this, right? So from A0 to A5, they are called the analog pins. All right. So, and they accept continuous stream of data. Now, I know in these digital pins, you can see something. There is a sign here. There's a sign here. And I don't know if you can see that. The sign is in pin 11, is in pin 10, pin 9, is also in pin 6, it's not in pin 8, it's not in pin 7. So I guess by now you should be able to identify what I'm talking about. Now, any pin that have this sign is called the pulse width modulation pins. The pulse width modulation pins. Now, they are there for a reason. For example, the analog pins accept the continuous stream of input data, maybe from sensors that are trying to get reading, get physical measurements from the environment or something like that. So it's an input device. And that is what the A0 to A5 does. But then when we want to talk about things that give out continuous stream of output data, that is when we talk about these PWM pins. For example, your motor. The motor I'm talking about is that rotating device. Think, yeah, this. If you can see this very well, this is a motor. So this is exactly what you connect your tire to. And once this is rotating, the tire will be rotating. That is a motor. But then you know that this motor is actually an actuator. So the motor is an output device. But this motor is not going to be 0 or 1. It's not going to be either off or on. Remember, we have to deal with the speed of this motor. At a point, we need to reduce the speed so that the tire will at some point stop moving. Okay, so that is exactly the kind of things that make us to use the PWM, pulse width modulation pins, for this kind of devices like the motor that is not just on and off, but they are not input device. Remember, the motor is not an input device, it's an output device. And we need to get the continuous stream of this motor to know, okay, the next speed we are giving to it, what speed is it at now? So when you want to connect this motor, you will need to connect to a pulse width modulation pin. Is either you connect this motor to pin 11, to pin 10, pin 9. If you connect it to a pin that is not a pulse width modulation pin, it will not work. That modulation will not work. Okay, So that is it. When you are connecting whatever you want to connect to this board, you need to also choose the pins you are using carefully. All right. Now, this is a microcontroller. Look at the item labeled 1 is the microcontroller. So the Arduino is a microcontroller board, is a development board. Other things are already on it. So for now, we are beginners and we are trying to use the Arduino, which someone else already built. This is the main thing, the microcontroller here, this particular thing. This particular place labeled microcontroller, that is the main thing called microcontroller there. That is the brain of everything. That is where everything is stored. That is where the sensors send information to. And it is this same thing that sends information to other devices connected to this Arduino board. So if you remove this thing, if you like screw out this particular microcontroller from the Arduino board, then the Arduino board is useless. Okay. Now, this is the GND. So if you understand your basic electricity, you know you have the minus and you have the plus. So the minus is always denoted with a black wire, all right? And the plus most times is represented with a red wire. So anytime you see red, you know it's the positive leg. When you see black, you know it's the negative leg. Okay. And remember, you won't join these two together. So even in your connection, you need to be very careful. When you are supposed to connect the ground, now the ground is the negative. Anywhere you see ground, just know it's negative. Just know it's the negative pin. So the ground is going to allow you to plug anything that is the negative. The negative. For example, the bulb you have, there is a negative leg and there's a positive leg. So you take the negative leg and plug in GND. You cannot take that negative leg and plug in 5V. As you can see, as it is labeled 5V, that means it is a live wire. It's giving out a voltage. Okay, so you cannot use the negative leg of a bulb to connect to 5V of an Arduino. You know, negative and positive won't go together. Okay, so this is just it. And then the V in, for example, maybe you want to, I know from here you can see there are 3 ways to on the Arduino board, or rather 4 ways. Yes, it's either taking power from this USB port. Maybe you plugged it to your system, then yes, the system is giving it some power and the Arduino board will on. If you have your Arduino board there, you can just take out that cord, plug it to this USB port, and then plug the other end to your system. You will see that the Arduino will light up because it is on now. And then the other way is using this power jack. This is called the power jack. So you can plug this, you can plug a wire to this and then connect the other end to a battery. There is a particular kind of wire that you can use for this. And that wire have these ports. So you can plug that wire to this and connect the other end to a battery. And it will give voltage to the Arduino. So the Arduino will light up. All right. Then if you don't want to do it that way, you can still connect, just take a wire and connect it to the V-in pin of the Arduino. This means voltage in. So you can take a wire and connect it to the voltage input pin of the Arduino, and it will light up the Arduino for you. Now, you can also connect the wire to the 5V pin of the Arduino, and it will light up the Arduino for you. So another thing I want you to know is that the Arduino takes in only 5 volts. Okay, so I know the electrical students here will like relate with me. In every device you're working with, you need to know the voltage. Whatever thing you're doing, whatever you want to connect to the Arduino, you need to know the voltage. there are times when a particular device, all right, so there are times when a particular device will not need up to 5 volts to operate. And you know the Arduino is giving out 5 volts. So in this kind of scenario, you will have to use a resistor to break down the amount of voltage the Arduino is giving to that device, just for you not to damage that device. But then there are some times that the hardware you are using, the voltage is bigger than 5V. But remember that the Arduino you are connecting it to can only give out 5V. For example, your fan now, you will see in your fan is leveled to 240 volts or maybe 50 volts according to the capacity of your fan. But then the Arduino can only give out 5 volts. So what if you want to automate this fan? How do you make up the remaining, maybe if your fan is 240, the Arduino is giving 5, that is 240 minus 5, that is 235. We are still looking for 235 volts before we can be able to switch on that fan. All right. So how will you get this? So it's always right to know the amount of voltage your device is taking, so that you know what else to do. So I'm still going to come to that part where we automate a fan, and then how can you top up the voltage? Which other device will you use to help the Arduino? Because obviously Arduino's 5V cannot power this fan. So what else will you do to help the Arduino to power this fan and stuff like that? So that is it. And then I already talked about the sensors, which we are going to see them today. All right. Okay, I told the people to download a particular, not to download, to sign up to a particular software, which is the Tinkercad. Please, I'd just like you all to open your Tinkercad. Just open the Tinkercad, sign in there. Okay, let me just wait for you. Please, if you are there, you can just, maybe raise your hand or something. If you are in this particular place, yes, you can raise your hand, please. Let me get up to 5 persons, then I'll continue. All right. I guess many people are there already. Yeah, you can raise down your hands now. I guess many people are there already. All right. Okay. So Tinkercad is just like a simulation software, just like a circuit design software. So it will actually help you, that particular circuit that we will design with Arduino, real life, that is physical. We can actually design it here and simulate it here, see if it's working or not here, before we can be able to build it physically. So if you have your Arduino starter kit physically, you can actually you can be following me physically. So as I'm trying to simulate this on this software, you can be doing your own physically. But for those of you who don't have the Arduino physically, you can join me while I do this. All right, so let's create a new design. We are creating a circuit design. All right. So this is the first thing you're going to see. Are we here? If you're here, you can just raise up your hand, please. Just wave. Okay. Okay, I guess many people are here. All right. So, but then there is a device that there is something that is very essential, which I didn't talk about. And that thing is this. Just touch this breadboard, okay, just drag it to this place and it will be out. Okay, let me delete one because I already had one. Okay, so this particular item, I didn't talk about it, and it is very essential. Okay, maybe you can just drag it out on your own so that while I'm talking, you'll be relating with me. Now, as you can see, there is a label here, minus, and there is a label here, plus. All the pins you are seeing, these are pins. These are pins. If I show you the breadboard physically, I'll still show you the breadboard physically. So if I show you the breadboard physically, you will see that there are pins that you can connect something to. All right. And if you hover on this, you see that all these are highlighted together. They are chained together. That means all these pins, they are all connected to each other. They are all connected to each other. When you give power to anyone, that means all of them will automatically have power. When you connect any of these pins to a battery, or maybe connect any of these pins to power, that means all these pins will have power. So these ones you're seeing, they will not have power. If I actually connect something, connect maybe a battery to any of these pins, the power ends in this line. The power ends in this line. So this one, they are connected differently too. As you can see, they are also changed. The whole minus, they are connected to each other. And the whole plus are connected to each other. Now this, I know when you hover on it, you can see the chain. You can see the chain. Okay, so that means F, J, F, G, H, I, J are all connected. They are all connected. And I know these numbers are actually what differentiated it. 1, 2, 3. So 1 and 2 are not connected in any way. As you can see, once I hovered on 2, you can see the direction of the chain, right? So 1 and 2 are not connected in any way. 3 and 2 are not connected in any way. Okay, so you can see the connection now. All right, so anything I plug here, anything I plug in here, that means every other pins, they are connected to the same power, All right, so that is the breadboard. And why do we need this breadboard? Why do we need it? For example, I think, let me show you something here. If you notice, I talked about GND, right? And I said that GND means minus. And I talked about 5V. And I said that 5V means power, that is plus. All right. Now, we might be trying to control up to 15 devices using just this microcontroller. Just this particular Arduino, we might want to connect 15 hardware devices to it. Now remember that each of these 15 hardware devices have their own negative pin. Okay, so each of, for example, I'm trying to automate 15 bulbs. each of these bulbs have minus and plus, minus and plus. And all these minus and plus must be connected to this Arduino so that the Arduino can be able to control it. But then we only have one GND. I think two are here. So we have two GND here, and I think there's another one here. Yes, 3 GND, the whole Arduino microcontroller. There are only 3 GND, only 3 ground, only 3 minus pin. So when we want to connect up to 15 devices, how then, when we connect 3 of these bulbs, that is the negative pin of the 3 bulbs, to this Arduino, what about the other 12? How do we connect it? Because obviously these pins, these 3 GND pins in the Arduino, they will be occupied. So how do we connect it? So now there are 2 solutions to that. The first one is either you solder them together. It's either you solder them together, the whole negative pins. It's either you solder them together and then connect them to the Arduino GND. That means if you solder them all together, that means you have only one pin to connect. And you can just take that pin and connect it to one GND and everything is solved. And then the second way is using this breadboard. So as you can see, the breadboard have how many minus pins here? 1, 2, 3, 4. You can just count it and see. And on this other side too, we still have minus pins. Okay, 30, yes, based on these numbers. So the breadboard have 60 minus pins on it. So whether we want to connect 60 devices, so we can use the breadboard can help us to do that. So we can take the minus pin of all those hardware devices we want to connect and connect them to this place. Just maybe you connect for the minus pin of the first bulb here, the minus pin of the second bulb here, the minus pin of the third bulb here, and that is it. So the breadboard helps us when we have, because we have limited numbers of pins in the Arduino, breadboard will help us. All right. Okay. Then, as you can see this now, there is no way to give power to this breadboard. Now, this breadboard is off. This is not even an electric device right now because there is no electricity coming through it now. So how then do we give power to the breadboard? Because we need to give power to this breadboard. Okay, then is either we take a battery. So this is a battery. I don't know if you saw what I did. I don't know if you saw what I did. This is 9V battery. I just dragged it out. So you can do that for yourself too. Okay. All right. So this is the battery. Okay. Let me make it very visible. I think this is okay. I don't know what's happening. All right. Yes, we're talking about the battery. Okay. Now, as you can see, okay, as you can see, this battery, if you over on it, you will see this is negative and this is positive. This is negative and this is positive. So if I want to give power to the breadboard, I will just hold your left click and then drag it. Left click and drag it to minus. Yes. This is minus, right? So it's supposed to be here. Remember, you are not supposed to connect the negative to the positive. And you're not supposed to connect the positive to the negative. So this is the minus pin of the battery. And I just connected it to the minus pin of the breadboard. All right. Then just left click again and drag this to plus. So this is it. Although you should try to make your design look like really beautiful at least. So, all right. All right, so this is what I have here now. With this, assuming I have these two things physically. Those that have them physically, maybe you can try it out. If you connect the plus pin of your battery to the plus pin of the breadboard and connect the minus pin of the battery to the minus pin of the breadboard will receive power. So the power of the breadboard is activated now, and anything connected to the breadboard has power. Okay, all right. I think this is just to show you one of the ways to give power to the breadboard. All right, then let's look at the Arduino. You can see where I got the Arduino, right? This is it, Arduino Uno R3. So you just drag it out. Okay, let me just place them well. All right, so you can see these two very well now. Okay, remember that okay, this is the USB port. As you can see, this is the USB port. You plug one to your system and you plug one to the Arduino. Then you can upload code from your system to the Arduino using this port. All right, remember that once the Arduino have power, anything connected to it, the power will also be transmitted to them. So another way to give power to the breadboard is to connect it to the Arduino. So remember that minus should go to GND of the Arduino, and plus should go to 5V of the Arduino. So this is exactly what I will do. Just left click and drag. All right. Okay, my GND is not here. I think I'm supposed to be going to this direction. My GND is actually here, but I don't want to use this GND. I want to use this, or I can still use it. So let me just, okay. All right. So I just connected this minus. So this is exactly what you do in real life. When you have these two devices in real life, this is exactly what you do. use what we call jumper wires to connect this particular pin to the GND of the Arduino. And then we connect the plus pin. Remember, we are supposed to connect the plus pin to 5V, that is the power pin. Okay, let me go this way. And yes. So our breadboard now is connected. Anytime we give power to the Arduino, automatically the Arduino gives power to the breadboard. Okay. Then if you look at this left panel, I don't know, is anyone actually following me? Maybe you can just wave your hand. Let me know if all of you are following. All right. I can see a lot of people are following. Thank you so much. Okay. Now, if you look at this right panel, you will see that there are so many devices and they are all labeled. So you see push button. All these devices you are seeing here, you can get them physically. So if you have your Arduino kit, you can just look at the things there. Maybe yes, I'm sure you will see this there. And these are resistors. They are all labeled in your kit. You will see an LED, just a small LED there. You will see your push button. So this is a button. You will see it there. Your potentiometer, that particular thing that you can turn. You can turn left or you can turn right. The potentiometer, you can see it there. A capacitor, you can see it there. Then your 9V battery, this is just like the microphone battery, the normal microphone battery, it's a 9V battery. You can also use other kinds of batteries, but if you are using a 1.5 volts battery, you know that it can't power the Arduino alone, which means you have to combine how many of them, maybe up to 4 of them, for you to get the 5 volts that can power the Arduino. All right. And then the breadboard, I'm sure you can see it in your kit, and others, yes. Okay, so yes, the micro servo, I'm sure you can see it in your kit too. So many other things. There are some you might not be able to find in the kit, which means if you get to a point where you need them, you have to source them, you have to buy them. Okay. I think I'm going to use this LED now. I'm going to use this particular LED for this. Okay, let me drag it out. Okay, I think let me just give it a blue color. Yes. Okay, so this is an LED. All right. This is wrong. Now, you can see that this LED has 2 legs. This one is straight. This one is straight, and it's even labeled. So, because it is a software, they will help you. So, they will label it for you. But real life, you have to identify them by yourselves. Sometimes they are labeled on the body too, real life. When you get them physically, they are labeled on the body. But you have to understand what you are doing. So this is the negative leg, and this is the anode, the positive leg. So the negative leg is always shorter than the positive. So whenever you take the LED, if you have the kit, you can just bring out your LED. Whenever you see that LED, you see that one leg is long and the other leg is shorter. So the longer leg is the positive and the shorter leg is the negative. So if you can see here, this is the longer leg. This is the longer leg. This is the longer leg. And this is the shorter leg. So this is negative. And in whatever we are doing, we need to connect this to negative. Remember, this is negative. So you have to be very careful in whatever connection you are doing. Remember, do not misuse this negative and positive. It can burn up this Arduino board. I'm sure those that have gotten the kit, I'm sure you know how much you got the kit. And the Arduino board alone is not less than 12,000. The board alone is less than 12,000. So if you can actually damage it by misplacing the connections. So where it is supposed to take negative, please give it negative, connect negative to it. And where the positive is supposed to be connected, endeavor to connect it. Just cross-check everything. And the worst thing is that it can even harm you. It can blow up and harm you. Of course, you know what electricity can do. All right. So you need to be very careful. And this, the anode, we connect it to the positive, but that is the positive thing. Okay. So this is just like the normal thing we know in electricity, negative and positive. Once negative is connected to negative and positive is connected to positive, the light will go on. All right. So I think you should just click here. Click on start simulation. Let's see what happens. Okay, you can see this. You can see this, the LED is on now. The LED is on now, but we didn't actually give it any command. We didn't give it any command, but it's on now. All right. So the next thing we are going to do, which is the reason why I introduced C++ to you, is to write some code so that we can use our code to control this bulb. So now, when we click on start simulation, it's just like giving power to the Arduino. So everything now has power. Or you start working. So that is it. So now the bulb is on, so it's working. But then we cannot even control this bulb. What do? We have to control the bulb using the code, which is the reason why you have these pins. Like I've explained, the pin, digital pin 13, digital pin 12, up to digital pin 0. All right. So I didn't talk about the digital pin 0 and digital pin 1. If you look here, you will see that there is an extra label on these two pins. You have TX and you have RX, which means pin 0 and pin 1 are left aside for TX means transmission and ROS means receiving. So pin 0 and 1 are left out for the Arduino to communicate with something else. So if we are looking to communicating with our phone using this Arduino board, then you know that whatever you are connecting, either the Bluetooth or the Wi-Fi, we are connecting it to pin 0 and pin 1. But this is the transmission and receiving pins. So we will not use pin 0 and 1. We just kept it aside for that. All right. So the pins we have left, we have pin 2, digital pin 2, up to digital pin 13. Those are the pins we have left. All right. So now for us to be able to control this, I'm going to delete this particular thing. The negative, the positive pin, that's the positive wire. I'm going to delete it. All right. So for us to be able to control this, we need to connect it to a pin on the Arduino board. So this breadboard is just going to give it power. It's just going to give it power. But then for us to control it, we need to connect it to a pin on the Arduino board, something like this. I think let's connect to pin 2. Yes. You can see that. I just connected this positive pin to pin 2 of the Arduino. Now, by default, all these pins, they are off. Okay, let me start simulation. Wow, nothing happened. Nothing happened, which means there is no power on this pin. Assuming there was power on this pin, then it would have lighted the bulb, but there is no power. So how do we give power to this pin? How do we make this pin to light up the bulb? That is where we need to code. All right, so just click on the code, then I guess you will see something like this. I don't know if you all can see it. Okay, first of all, let's stop simulation. Please stop simulation first. Yes. So you cannot actually be running it and then writing code too. That is for the software too. All right. I know once you start simulation, this appeared. So you can click on block and select text. Continue. So you will see exactly this. Please, you can wave your hand if you are here. If you are seeing this code right now, please just wave your hand. Oh, great. Okay. I can see more hands. Oh, thank you very much. All right. So we are going to, this is just the default code that we are going to delete it. This is the default code that we are going to delete it. We have void setup. When you run your Arduino code, when you open up the Arduino software, you will see void setup and void loop. It's just there. Okay. Now, the setup is where you set your devices. This is where you initialize your devices. And this setup runs only once. I think you're understanding the reason why I took my time to go to loop in C++ before coming here now. Void loop does the same thing that C++ loop is doing. So the void loop keeps on repeating every code that is here. Once it's run the code, it will come back again and run it again. It will come back. But this is an infinite loop. It will keep on running. It doesn't have an end. That is the Arduino loop now, the void loop in Arduino. So this is already defined somewhere that I should continue running this particular, every block of code inside here. You should continue running it. All right, and that is why whatever you are automating, you continue working and nothing will stop it. Okay, but then the void setup will run once, only when you switch on the device. That is when this void setup, anything in void setup, that is when it will run. I don't know if you got that. All right, so what do we need to do in void setup? First of all, let's define our pins. Remember, we connected this LED to pin 2 of the Arduino. So this is exactly what we will do. Int, declare your variable, your integer variable, because we are dealing with numbers here. Int, just name it anything. What am I going to name it? Maybe LED. Int LED is equal to 2. Right. So LED is connected to pin 2. Anywhere it sees LED, that means it will understand that we are talking to pin 2 of the Arduino board. Okay. Then the next thing is to set this up, initialize whatever device we are using. Now, LED, is it an input or an output device? LED is an output device. So this is exactly what we are going to do. Pin mode. Remember, Arduino is case sensitive. So anyway I write this, just follow me to write it simply. If I write with capital letter, write with capital letter. And if I write with a small letter, write with a small letter. All right. So M here is in capital letter. Pin mode, LED. You add your comma. And then set the state of this LED. Is it an output device or is it an input device? If it is an input device, then I'll say input. So this must be in capital letter, please. If it is an input device, then I'll say input. But since LED is an output device, I will write output instead. So now I've set my device up here just with this line of code. All right. Then how do I switch on this device? Digital write. We are writing, remember, we are writing to this pin now. We are writing to it. Digital write, LED, LED. So what are we writing to? Which pin, which particular pin are we writing to? LED, which is pin 2. Okay, what are we writing to LED to? Remember, you can only write one or 0. That is the only thing you can write. But then 1 is high. High means it's going to give power. So that is 1. 1 is high and 0 is low. So if we want to on this LED now, we will just write high here and the LED will switch on. So let's try this. Just start simulation. Let's see. All right, I think I have an error. Remember your semicolon, please. Okay, start simulation. Okay, you can see. You can see this. The bulb is on now. Stop simulation is off. Start simulation is on. All right, I don't know if you got that. Maybe you can just wave your hand if you got that. All right, thank you so much. Okay. Okay, so that is it. Let's stop simulation and continue with the code. Now we want to do more things. Let us delay. Delay means just wait for some time. So remember, we are counting in milliseconds. So instead of 1, we are counting in milliseconds. All right. So if we want to delay for 1 second, that means we times 1 by 1,000. So 1 times 1,000 is 1,000. So that means we will delay for 1,000. That is for 1 second. We delay for 1 second. All right. So after the delay, what next? Let's say digital write LED low. All right. Remember that this means switching it on and this means switching it off. So we will switch on this with this bulb, delay it for 1 second, and then switch off the bulb. Let's start simulation and see. All right. Okay, this bulb is still on, it's not off. Okay, I think I wrote that before with a small letter, right? I think I wrote that before with a small letter. All right, let's see. Okay, let me delay for like 2 seconds. Okay, I can't write when I'm still simulating. Let's say 2 seconds. All right.
Try maybe low as well. I think that will solve that problem.
Sorry, I didn't hear that.
Below, I think you should delay it as well. After, because you need to delay the off
Oh,
position so that you can stay off well
okay,
and go back.
okay,
I think
yeah. Thank you for that. Okay, I don't know if you understood what's going on. Immediately, I'm not delaying this off. I'm not delaying it. So immediately it goes to off, it will go back again to on. Remember, we are dealing with loop. It will go back again to on. So it will continue, and before it will off and on. So it will just remain on. Yes. So if I delay this now to see it very well, let me delay it for 2 seconds. All right. Okay. So it's working now. Okay, if you are here, maybe you can just wave your hand. All right. All right. So this is exactly that almighty thing that you feel like maybe someone used to build. So when you continue studying, when you continue like getting used to all these devices, learning how to connect them, how to control them, how to write your code to control them. So just exactly after writing this code now, if you have the physical hardware, you will upload it. I'm not using the Arduino ID. So this is where you need the Arduino ID now. If you are using it physically, you need the Arduino ID. So after writing this code, you just upload it, use it through this USB cord, like I said, through this USB cord. You upload it to your Arduino board, and everything will start working the way you connected it physically. All right. So this is it. All right. Yeah.
hello. Sorry, please have a question.
Yes, I think I'm going to deal with questions now because I'm done for the day. So yes, you have assignments too. Okay. So yeah, you can ask your question.
So, sir, I connected the LED to the 9-volt battery and it blew up.
Sorry, I didn't hear you.
I connected like I plugged the 9-volt battery to the breadboard and used my LED on it and the LED blew up.
And the LED blew up.
Yes,
All right. Sorry, thank you so much for that. You did it physically.
yes, I did it.
Okay, sorry for blowing up your bulb. Sorry for that. I missed something. Okay, this is just a software. So
Hello,
some
good
things.
evening. Hello, good evening.
Hello.
Good evening. Please, we
Yes,
take
good
question
evening.
one after
Please,
the
I
other.
want
Thank
to ask a
you.
question about the
Sorry,
code
please. We
aspect.
take questions one after another. So let me
Emmanuel,
answer this
hold on.
first.
There's a question on ground. You raise your
Okay,
hand to ask a question. When you are called, you answer.
okay,
You
that's
ask a
fine.
question. Thank you.
All right. I'm going to delete this particular line because that is where the problem came from. Okay. So sorry I didn't tell you, like I mentioned before, you need to know the amount of voltage you are working with. You need to know when to add resistors, which will break down the voltage, which will like regulate the voltage is given to your device. And you need to know when to top up the voltage. So just like I said, Arduino is giving out 5 volts. This is it. We connected the breadboard to the 5 volts of the Arduino. So the Arduino is giving out 5 volts. But then this small LED you are seeing here, please, this LED is not supposed to accept up to 5 volts. It's not supposed to accept up to 5. I think this LED is 3 point something volts. So you see that the 5 volts Arduino is giving to it is too much. And if you connect this directly, it will blow the bulb. That's exactly what happened to you. Sorry for that. Okay, so now what will you do to solve this issue? This is it, resistor. You need to bring a resistor in. I don't know if you can see a resistor in yours. I don't know if you can see a resistor in your own. Maybe you got the starter kit or something. So I just added the resistor here. Remember, these pins are connected. These pins are connected. So I'm going to drag the positive leg of this bulb and connect it to the pin where this resistor is connected to. Yes. I don't know if you're following me. And then I will connect this is the other leg of the resistor. So the other leg of the resistor, I just connected it to the other end. So I'm going to drag it from here to pin 2. Yes. So this is exactly what you would have done. So while power is coming in from pin 2, 5 volts is being released. It will come here and then the resistor will regulate the voltage and then give the amount of voltage that this bulb needs to the bulb, and it will maximize the battery life, the life of the bulb, and it will not blow up. Sorry for that. I don't know if you got that.
Yes, I got
Okay. Yeah, I can take the next question now.
Okay, good evening.
Good evening.
Hello.
Can you hear me? Yes. I wanted to ask, when we using the Tinker card,
Yes.
you told us to go to logs, to go to test. Is it possible to also run this code using the blocks that were provided?
Yes, it's possible to run the code using the blocks that were provided. Those blocks are just guides, but then I want you to get familiar, because in Arduino you will not be using blocks. You understand? So in Arduino,
Yes.
the Arduino IDE, you are not using blocks, you are writing codes. So that is why I wanted you people to use the text. Let's write some code. Yes.
So is it possible to also copy the codes you have here from your simulation to Arduino IDE?
Yes, it's possible. This code is exactly the same thing you would write. It's just like when I removed this. You can see start simulation. There is an error. To try an error there. Yes. You can see an error, right? So that is
Yes,
exactly
yes.
what happened in the Arduino IDE. Whatever you are seeing here, when you copy it to the Arduino IDE, is correct.
Okay.
Yes.
Thank you.
All right. Thank you. Any questions?
Hello. Good
Yeah,
evening.
Emmanuel. Yeah. Good evening.
Yeah, good evening. Please, I want to, because I wasn't in the class the first day we had this section, so
All right.
not like I'm dragging the class back, but I would like you to like give us what is it called now? I'd like you to like recapitulate a little bit just for me to have a refresher on how you wrote those code. I saw that you normally start with a forward slash, then you now put C plus plus. Is that a standard? That's number one question. Then number two question.
Okay.
Okay, number two question is thus on the Tinker card, I saw that you said we should enter with the link that was provided. I've created an account because I've never had an account on the platform before, but I
All
wasn't
right.
able to follow a live section with what you're doing. So unless I come to this normal platform where you're talking and we are seeing what you're doing. So I don't know if there's a procedure for one to actually be seeing it. I mean, being in the class directly, because I saw the first dialogue box there was talking about class,
Yes.
tutorials, and I can't remember the third one now. So
Okay.
is there?
Okay. I don't know. Were you here throughout the class? This particular
Yes,
class.
yes, yes,
You've been here
yes, yes,
when I started. Okay, I
No,
started and
I didn't start with you actually. I entered midway, but
oh wow.
I think from the initial state, most of the things you've taught, I was listening to what you were saying, but I didn't get how you entered the Tinker class, Tinker card class, obviously.
All right. Please, you should just try to be here because this is a practical class. Anything you miss, you'll be as good as missing the rest. All right, because I know you didn't join this particular thing I did now because you missed that one thing I did. Okay. Think let me go back to my account before I came here. Okay, so this is
Sorry,
my
can I?
dashboard. This is what you're seeing, right?
Yes, yes.
All right. So what I did to get to this place was I clicked on designs. You can click on it. You can see that, right?
Yes, I can see designs.
Then click on create. You can see this, right? You click on circuit and it will take you to
Okay.
this particular place. Yes, you can see that now. So whatever I'm doing, you will be doing also with me. So you missed that particular step and it's as if you couldn't follow anymore.
Yes,
All
that's
right.
true. I saw.
And then for the code you talked about yesterday, all right, you're seeing 2/ here because I think those that were here yesterday we understand what I said about comments. This is a comment. So
Okay.
it's just like a way to describe the code I'm writing. The compiler will not execute this code. Once it sees 2/, it will know that I'm writing a comment. So
Okay.
you can see this is a description, C++ code. I'm just trying to describe the code I want to write, that this is a C++ code. I can come down
Okay.
here and say, I can come down here and say, okay, let me stop simulation. Yeah, I can come down
Okay.
here and say / initializing the devices. So this is like a comment, a description of what I did here. So the compiler will not run it. That is why I started with this. Yes. And then for
Okay.
that particular class you missed yesterday, I won't be able to because that is a coding class. So it's just like I'm going to come to start coding today. You can go to YouTube.
Okay.
I guess the link is on the group now. Go and watch that
Yes.
previous class, please.
Yeah, yeah,
Yes.
yes, yes. I'll do just that. Okay. Just my last question before you just talking about, I saw that inverted bracket. I mean, the bracket that looks like a set. I don't know what
A
it's
curly
meant. What
bracket.
is
That's called curly bracket.
sorry?
That is a curly bracket. A curly bracket.
Okay, curly bracket. Thank you. Thank you very much.
Thank you. And that is used to open up a block of code. And then, so whatever you are writing inside this is a block of code.
Okay, so by the time it opens, it means you have
All right.
opened a block of, and then you now close it by taking it the left way.
Yes, you close it. So when you close it, this has ended. This has ended.
Okay.
So, but because it is loop, if you were here when we are treating loops, because it is loop, that means we are going to keep repeating this particular code. When it runs and come down here, it will go up again and start from beginning. Not from beginning, not from here, please. It will go up and start from the place where the loop block of code opened up. Are
All
you
right.
there? And it will run
This is
again
quite
the same way.
interesting. Very interesting.
All right. Okay. Any
Thank you.
other question, please? Thank you,
Thank
Daniel.
you.
Okay, good evening.
Good
I don't know
evening,
if I'm audible
Uchenna.
enough.
Yes, you
Yeah,
are.
thank you so much. Yeah, what a good way to kick the ground running. Oh, wow, it's so amazing. It's kind of like so enjoyable. Well, I never
Wow.
thought it's gonna be this. I know C++ is tough, C, I know, but But it's quite amazing. You did a great job. I got a lot of questions. I don't know if I could run them down, all of them. But I'll pick the ones I
Okay,
think they
that's
are quite very tough for me. Now I'll pick
all
up
right.
from I don't know. Can you go back to the Arduino board? The PW, is it PWM? PWM.
Okay,
So wait, sorry.
yes.
Yes.
You can see
What's the name again?
it's visible, right?
Yes, very visible.
Okay.
What's that again? You called the name.
Pulse
Um,
width modulation.
okay, pulse width modulation. I want to
Yes.
know. So when you were explaining, I didn't get it very well straight. Like,
Okay.
what's that? Because you told us about the hyphen close to the numbers, probably number
Yes.
11, 10, 9, 6, 5, 3, 3. So, and
Yes.
what's the function and what is the necessity of those things there? Um, that is one question. Should I go on?
Okay. Yes.
Okay, and then I can see the transmission and the receiver, which you talk about the TX for 1 and TX for 0, the TX for 1 and TX RX for 0. I'm still seeing that on the board again, which I think is a LED
Okay.
on the board. Yeah, I don't know
Okay.
if you can see it also. Yeah, is it
Yes.
the same thing or that's just a signal point for it?
So I didn't get that.
Do you understand? The TX and the RX, it
Yes.
is written twice on the board, right?
Yes. It's written
So you said
twice.
yes. One is written in 0 and 1, and the other one is written on this
Okay.
LED, which is close to the Arduino write up. I don't know if you could see it.
Okay. Okay. Okay.
Can
Okay.
you?
Yeah, I got that. I
Yeah.
got that.
I think is that the signal maybe for kind of light LED for signal or something, or what's the use? And then should I continue my
Okay.
question?
Yeah, I can hear you. Okay. Okay. I think I will have to answer this.
Okay. All right.
Okay. I think I'll have to answer these two now. When I
Okay.
talked about the PWM, okay, I said that the PWM means pulse width modulation. And I know you saw exactly what I did, the way I connected the bulb, right, to pin 2 of the
Yes, ma'am.
Arduino, right? Okay, and
Okay,
when
yes,
I
ma'am.
sent signal to pin 2, the LED turned on or whatever. I was able to control the LED using pin 2 of the Arduino. Now, I said that the digital pins receives only high, right, or low, 0
Yes,
or
on and
1,
off.
on or off. That is exactly what it receives. And then the analog pin is for continuous stream of input data. Those kind, maybe
Yes.
like sensors that needs to keep streaming data in,
Temperatures you
like the
mentioned.
temperature, the photoelectric sensors and all that. But then there are also output devices that needs continuous stream of data. Something like the motor. You can see this, right? This particular thing.
Yes, ma'am.
Now, this is a motor. This is exactly what is responsible for rotating the tire of your robot. So remember that this motor, once it's rotating, we need the speed, right? We need to control the
Yes.
speed. There are other things to control, but this is an output device. This is an output device. So we need to like decrease the speed. We need to increase the speed. It's not only high or low. That is it for this motor. So this is where the PWM comes in. If we want to connect that motor to the Arduino, we must connect the motor to one of the PWM pins. Are you getting me? So that we
Yes.
can be able to write values which are not 0 or 1 to that motor.
Okay.
Did you get that?
Yeah, I'm
So
trying
if we
to.
connect that motor, if you connect that motor to pin 7, if you connect that motor to pin 7, which is not PWM, that motor, we can't control that motor. I get it. We can't write to that motor. We can't because when we are writing to the motor, we are writing the speed. We can say, okay, let the speed be 25, let the speed be 100, let the speed you get. So it's no longer 0 or 1. And remember, for each of these digital pins, we can only read and write 0 or 1. But for this kind of devices like the motor, if we want to read or write something more than 0 or 1, we need these PWM pins. So we have to connect the motor to either pin 11, pin 10, pin 9, just any pin with PWM. So I don't know if you got that.
Yeah, I think from what I understood is the PWM is used for output output signals for when you need to
Yes.
run more than 0 and 1, and then the
Yes.
analog is for input, right? Where you need to run
For
for
input.
more than 0
Exactly.
0 and 1. Okay, I think I
Exactly.
get that now. I get that very well.
Exactly.
And then what about the
Okay.
temperature? Sorry, the the receiver
All
and
right. All right. All right. So
stuff.
I
Yeah.
talked about the TX and RS. So the TX is transmission and RS is receiving.
Yeah.
So when you want to work with maybe Wi-Fi module or Bluetooth module, so for the projects where you can talk to your phone, are you getting? And then your phone will
Yeah.
send signal to the Arduino. This is exactly the pins that you need to connect to. So you need to connect your Bluetooth or your Wi-Fi to this receiving. That is the work of these 0 and 1 pins. But then you can see this. You can see, sorry, the TX and RS here.
Yeah.
You can still see the TX and RS here, right?
Yeah.
So it's trying to denote that the microcontroller just received something.
Oh, okay.
So you
Kind of
will
a
see
signal.
it light up. Yes, kind of a signal. You will see it light up. Yes, you will see it light up, right? And even when you plug your Arduino board, you will see it light up.
Okay.
When you
Wow.
send like you can
Oh
hear
my
me, right?
God. Yeah, of course I can.
So
Go on, carry on.
okay. So when you send your code to the board, this RX will light up. It's receiving something. So if you have a physical board there, you can just write your code. You can just write your code and then use the code. Upload your code right there to the Arduino, and
Yes. Okay.
it will give a signal. So those are the signal pins that is receiving and it is sending something. Are you getting me? So it's the communication
Yes.
pins which Arduino can use to communicate to devices connected to it. Yes, that is it.
Okay. One last question. Sorry.
All right.
Can I
All
go
right.
on?
Yeah.
Back to the breadboard. Back to the breadboard.
Okay. Okay.
I saw you connected the resistors. I know if you're building traffic lights with, I don't know, using the resistors. I had the different types of resistors. I don't want to go into that part first, but for the sake of this
Okay.
lesson, I saw you fixing the resistors just and I think, should I say, anywhere, but I know it's
Yes,
from the other
just
side too.
anywhere.
So after the red line and the black
Yes.
line in the ABC and then the FG, so those pin, all those holes there, are they positive or negative, or they are just neutral? Let me understand,
They are
please.
just pins that when you connect it to anything, it will work. So they
I
are
don't
just
want to get
pins that
my
they are not.
board blowed.
So they are just signal. They are just signal pins. They are just signal pins. You can connect anything. You can connect anything to it.
Okay, like let me. I want to get it straight. Because you spoke about positive, how to be careful where to put the
Yes.
positive or negative. So are they neutral, or they will have to follow a line or something with them?
Like I said, I just showed you something, right? You can see what's happening
Yeah.
when I hover on this. You can see the
Yes.
chain. They are connected.
Yes.
So in
Okay.
case I carry my wahala and come and connect negative to this thing, are you
Yes.
there? Just remember
Yes,
that
ma'am.
every pin here is already negative.
Becomes negative. All right.
Yes. So that is the chain
Right.
connection there. That is the chain connection there. Every pin here becomes
Wonderful.
negative. 21 is out of it. 21 is not part of it. think.
Okay.
Yes, you can see 20 is not connected to 21. So I can connect a
Okay.
particular thing here, and I will connect something else to this place. Are you getting me?
Okay. Yeah, sure.
So it's just like exactly what I did here. I connected the positive leg of this this LED to this, right? I connected it to this place. Then
Yes. Yeah.
I connected the resistor to this. That is because I want to connect this resistor to the positive leg of my LED.
Mm.
Are you getting me? So once I connected
Yes.
this positive leg, that means everything here. Okay, I think there is a signal coming from here, right? 2. This is pin 2, right? And
Yes.
once I do
Pinto.
something with pin 2, it will go from here down, and then this is it, right?
Yeah.
Now this resistor is still connected to this place. Remember, it's just a way of extending the connection. So this is same as pin 2, because from here the wire is connected down to pin 2, right? So this is same as pin 2.
Yes.
I just connected a resistor from that pin 2. Are you getting me? To the positive
Yes.
leg of my LED. I did. Now, let me do this. Let me bring out another LED. Now, let me connect the positive leg of this LED to this place. Remember, I cannot connect the negative because this is already a positive. I get, because pin 2 is bringing power, positive power. So I
Okay.
can't connect negative to it.
Yeah.
So I just connected.
Mm.
Did you just see what I did? I just connected
Yeah.
the positive.
A
And then I
positive.
will connect the other leg to GND, which is where it belongs. Okay, let
Negative.
me start simulation. Did you see what's going on? The
Yeah.
two bulbs are working
Awesome.
together because they are
Awesome.
connected to one pin. The same pin is holding them.
Interesting.
So I don't know if you understood it now.
Very well. I do. Very well. I do. Thanks a lot.
Okay. Yes, thank
Thanks so
you.
much.
I don't know if anyone else have any question. So I wanted to show you guys the Arduino physically, but then I don't have light here. So tomorrow we are going to work on the Arduino physically, no longer using the simulation. So before my system will go off, I think I'm going to put up the assignment on the board. Sorry, on the screen. All right. So this is the assignment. Okay, this is the assignment. Yeah. So don't say you can't do it. Don't say you can't do it. If you don't have the physical Arduino kit, please use the Tinker card. Please use the Tinker card. You know, you learn by practicing. Even beyond what I teach you here, if you go and try it out, you will learn a lot of things. So that's why I'm putting up this assignment. Please try it out. And then you can tweet with IoT with Helen. Just tweet with the hashtag showing up your assignment there. It will also help you, at least, yes, people coming to your Twitter will know that this person is someone who is interested in this part of tech. Look at the things he or she has been doing. So you can tweet with this hashtag, and then I'll come there and look at what you've done so far. So if you are using the Arduino kit, you can make a recording of what you did and tweet. Just like the way I do it, you're following me up the way I do in my videos. All right. And then if you're using the Tinker card, you can also make a recording and tweet. Okay, please, I want to see this assignment. Please. I'm very glad the last assignment, so many people showed me their own. And I was very glad. At least I have a lot of people who are following up. All right. So in case you are looking for your photoelectric sensor in the Tinker card, Okay, this is it here. Okay, you can see that photoresistor. That is a photoresistor. So you can drag it. Yeah, you can drag it out. So you go online, learn how to connect this photoresistor to your Arduino. Learn how to write the code and read from it. All right. Please, please, please. You can just take a screenshot of this. You can take a screenshot of this. Let me show it. All right. So you can take a screenshot of this, please, and try it out. Okay, I don't know if anyone else have any question. Sorry, does anyone else have any question required? Yeah, you can ask a question, please.
I have a question.
Yes, yes, yes.
Hello, good evening. Can you hear me?
Good evening. Yes, I can hear you.
Okay. Okay, so to be honest, my network has been so redundant, so I didn't quite grasp many of the things. But I guess I might perhaps just check on YouTube to be able to do that. When you connected the resistor, what's the value of the resistor you said? Like how many ohms resistor? Like the specific ohm you used on the to bypass the current.
Okay, in your physical listing for, because this is a software, they won't specify. So I know I didn't talk about the resistors. So this is also an assignment I'm giving to you guys. Please go read up on the resistors. There are various kinds of resistors. We have the 220 ohms resistor, we have the 1K ohms resistor, the 10K ohms resistor, and lots of it. So you need to know the kind of resistor you will use based on the project you're handling, based on the device you want to control. So you need to know exactly the kind of resistor and the color. This color you're seeing here, they vary. If you see the resistor real life, you will see that 1K resistor, the colors there are different from the colors in the 220 ohms resistor. The same thing with the 10K ohms resistor, the colors there are different. All right, so just read up on the resistor. Just read up on the resistor. Get the color codes and then the difference between all of them. When to use each of them. Please read up on that.
Okay. So the code you provided to the Arduino. So I kind of get lost on network when you were trying to automate when you connected the red bulb to the Arduino. So I don't know, is there any way I could probably read up on the code? Okay, so
you can snap this code and then read up on it. You can see the code, right?
yeah, sure.
Yeah, so you can take a screenshot of it. So you can just read up this PIP mode. Why did I use it? The digital, right? Why did I use it? What am I actually trying to achieve? The delay, why did I use it? So I guess those that were here understood why. So I won't really go to it because of time. We don't have, I think we have 5 minutes left. So yes. Yes, so I think I was answering a question, or I don't know. Are you okay with that answer?
Like, are you talking to me?
Yes.
Yeah, I think I asked the question last. Yeah, I'm quite okay. So,
are you all right?
Sorry, one more question.
Okay.
Can you?
Yeah, I can hear you. Yes, I can hear you.
I'm having serious network issue. Okay, so it is okay. So the Tinker card if I'm right, the simulation software or the physical
Yes.
simulation environment. So I'm trying to achieve the same thing which you just did.
Okay.
Is there a way I could use a Raspberry Pi instead of Arduino and try to achieve that with a Python source code or something?
Well, that is another thing, a whole lot of something else. So this, I'm working with the Arduino board, and I wrote the code for the Arduino board. So I think you should just go online and read up on that. If you want to use Raspberry Pi, then you should read up on that.
Okay, thank you.
All right, cola, yeah.
Okay, you said you're going to talk about how to increase the power for the
Okay,
graphic set.
yes. Yes. Now, exactly tomorrow, what we'll be doing is automating the fan. I know most of you that have watched my video, yes, the voice controlled something I did. So that is exactly what we are going to be doing tomorrow. And that fan, we need to top the voltage to be able to control it. So tomorrow, you are going to see exactly what I will do, what I will introduce to you, and what I will do. Yes. Tomorrow, I will answer that question.
All right.
Okay, I think there are no more questions from anyone. All right. Okay, so thank you very much. Thank you all for attending the class. Thank you so much. So please endeavor to work on the assignments, please. At least by tomorrow. Tomorrow is the day we are ending this class. So by tomorrow, you should be able to follow everything I'm doing. Because tomorrow I'm going to be doing a live something. So when I'm working on it live, you should be able to follow up with me tomorrow. Thank you so much. All right. Good night, everyone.